My talk is going to be about the data management and the analytics for industrial IoT, right? So we would have came across many talks doing machine learning on top of IoT data, doing AI on top of IoT data, but there will be very less talks or very less knowledge sharing happens around data management. And that's why I intended to present about the data management as well in terms of IoT sector, because only if you store the data, you'll be able to analyze it, right? So the first step happens in about the storing the data, right? So that's the major thing that happens around. And the advances in technology continues to drive change in industrial operations, right? From the historical background, if we see the mechanical devices or the machineries were being built by hand, right? Everything from the welding to molding, everything will be happening by hand. And from that, slowly the smarter tools came into picture, where still people were using those tools and improvising the manufacturing procedure, right? And later on, with the help of humanoid kind of machines, people started to build products fastly than before, because they trained the machines to act faster based on what they need, right? Whether it should be a welding process or whether it should be an assembling process, they trained that machine. And now the latest sector, completely the robotics in industries has started to emerge. They themselves take decision based on the steps in manufacturing devices, and the manufacturing gets more faster, right? So as we all see from these stage 1, 2, 3, 4, fourth process where we are right now, businesses seek to leverage these advantages, right? And from our side, it's important to understand that how different technologies impact the operations, the manufacturing operations. And for all these improvements, the basic thing that lies is data, right? The data that gets generated from the sensors which have been installed in the specific machineries parts, and those applications have especially the potential to dramatically affect the industry's processes, right? Because they do generate a lot of data. So in this short session, what I'm going to do is let me dive into the data management portion of industrial IoT applications, including a basic understanding of what time series data is and how you can set up the data management platform in on-premise and in cloud, and maybe both cloud plus on-premise options as well, and what are all the advantage and disadvantage too. So as Mr. Murthy has introduced, I come from a complete data background and from a product company as well, where we build product for data, right? You would have heard about the big data technologies like Hadoop, Spark, and all those things, right? So the company where I work in Syncfusion, we built a product for big data that can be installed in Windows, right? In Windows laptop. So not just working on big data, I was also part of the team where I built the product as well for the big data and of course business intelligence as well. So holistically, I was able to see all the different services that are present, from the data generation, data ingestion, data storage, data computation, till data visualization. Till all these journey, I was able to work into different products, and I'm able to see it clearly how it impacts different businesses, not just IoT, not just fintech business. In all the businesses, data plays a major role nowadays. Of course, I'm also a Microsoft valuable professional for the data platform MVP. And yeah, and I used to always participate in events especially community events where I always love to share the knowledge and also learn from it too and connect with people too. So my quick agenda is going to be like, let us see what is meant by decentralized decisions, right? Everything resolves around decision making. From this moment I'm talking, right? I in my mind, I'll be thinking that what I have to decide next, what I have to talk next. So I decide something. Similarly, if you are buying a product in Amazon, while you're searching the product itself, or while you are go through a product itself, that particular page will instantly show you the recommended products which you might like and you might buy also, right? So in that case, the mission or the app takes the decision. So everything is going to be the decision making, right? So I'm going to talk in terms of how this decision making is present in IoT sector. Next, I'll talk a few words about time series database, and next let us see about uh, analytics perspective in IoT, and let us see when we would need real-time analytics, when we would need the deployment in cloud or on-premise kind of thing. And of course, finally, I'll also show you a demo of a complete deployment where the time series analytics can be done. So the decision making, right? This particular thing has evolved, I would say, kind of thing. And when it comes to IoT sector, the devices, the data, the monitoring, all these capabilities were present far beyond, maybe 50 years or 60 years back itself, right? Um, Let me tell you an example. Before 50 years of that particular time, uh, there will be farmlands where they'll store the wheat, right? Well, they'll store the wheat. And in US and Europe countries, since the climate will be too cold or too hot, at that time itself, they will be having some sensors which will be monitoring the temperature. And once it goes too cold or too high, it will raise an alarm, right? So that was the way old device. And what happens now? Similar kind of device is present, but the advancement in technology has enabled that not just raising an alarm inside that warehouse, it will intimate the respective person who might be sitting somewhere remotely as well in his mobile app or in his web app or whatever it may be, right? So let me tell a simple example of this decision making, how it happens, either it is centralized or decentralized. For the simplicity of understanding, I have took the example of Amazon Echo, right? Which we most of us would use in our homes, right? We used to play songs, and we used to connect with other IoT devices and all those things. So in this Amazon Echo, there are two portions are there. One is the centralized decision part is you will be asking that Alexa, play me so and so song, right? In that case, actually that particular device doesn't know anything. It will just accept the voice input, do the cleanup, do the conversion of analog data into digital data, right? What I speak is analog, and what machines can understand it's digital, right? So it will convert that analog data into digital data. It will send to the cloud, and that cloud will recognize that what is that particular song, and the cloud will return as data packets to play that song. Similarly, the same thing happens when it is being connected with the devices also, the lights or the fan, whatever it may be, which we are using, right? So the same way, it will go to the cloud, it will go to the service, and it will authenticate whether it is from the right person also, and it will reply back, and the action that happens, either it could be switching on a kitchen light, or turning on a fan or something, right? So so as we could see, the decision making happens in the cloud or in the internet, right? Now let us come to this IoT decentralized platform. So in the IoT space, they call it as edge computing, right? So what is meant by edge in English, right? If I have a square, this particular thing is called as edge, right? This particular whole square, this particular thing is called as edge, which means to the closest to the sensor where that IoT device is fitted. As you could see, let us consider automated cars, right? Automated cars would be having a lot of sensors that has been placed from the wheel, from the accelerator, from the clutch, from the spin wheel, from the dashboard, lighting, temperature, and the directions, wind, everything, right? So in that case, there will be some smart systems installed within the car itself, right? Which should instantaneously take decisions based on the scenarios that happen. Scenarios means based on the data that gets generated. For example, if some motion is detected before the car, before the automated car while it is driving, it shouldn't wait for the cloud. The data should be sent to cloud and something should be returned back. The decision of stopping the car should be very instant, right? Uh, uh, if not, it might lead to some catastrophe as well. It's not an easy thing to be gone around. So in that case, the edge platform itself will be having some intelligence present within the device itself, and that device will be taking the decision, right? So that is why it is called as decentralized. It is not always from the device gone to cloud. The decision happens there and the decision comes back to the device. Based on the situation, the decision happens in the device area itself. And of course, few data or few complex things goes to cloud. Mostly that will be less time constraint, right? Or that will be kind of low priority kind of things. Of course, those things, it will go to cloud and some decision might be happening. Let me tell with an example with the same automated car itself. Uh, for the wheel alignment, right? Let us consider that some data is being generated and that data is being sent to cloud constantly, maybe once in a second or twice in a second. And the machine learning algorithm detects something awkward that for this particular runtime for this today for current day and for the temperature that relies around the car, the wheel or the bearing sitting behind the wheel should not get so heat, right? Something is going wrong, right? Like this, the ML algorithm might predict in the cloud, right? So at some point of time, the driver might get an alert that the wheel is getting heat. Maybe you have to rest down your car so that the bearing can get cool, or maybe reach out to the nearest service station and check out your wheel alignment or the wheel bearing for your safety, right? This is something that not so serious and kind of alerting kind of thing, right? So in this case, the decision that there might be a problem happens in the cloud, and the taking the decision is being left to the driver or left to the user who is sitting with the device, right? So this is a kind of centralized decision that also present in the autonomous car itself. So when we see here, it's all about when we see the analytics in IoT space, it's all about getting the operational insights, right? So what I mean by that operational insights means, let us talk in a business language that short-term benefits, long-term benefits. The short-term benefit is going to be maximum that device has to be utilized, right? So that maximum the production we get, maximum we sell, maximum the profit we get. So it's all the short term of business. Maximum we use that resource, right? Whereas medium and the long term is nothing but the downtime has to be reduced, right? Downtime, what I mean is the device getting repaired, the device doesn't function to produce any input, or the production unit gets stalled, kind of thing, right? So in this perspective, let me tell with an different example kind of thing. Even let us take this telecom example itself. Earlier, I have just put an image about oil and gas, but since I got this message today morning, I just thought to put it here itself, because most of us will be getting such messages, right? So as you see here, the first message, it says that Airtel is sending me, the customer, right? I get a message that I might face a service disruption because the Airtel is on the regular maintenance activity on 12th of February, right? That is on the next day, not on the current day itself, right? So it is something that Airtel collects the data from its communication towers constantly, and it will predict some around that monthly once the service should be done, right? In that case, while it is being serviced, well, of course it will get switched off and the user will get affected, right? So based on the data collected from those communication towers, Airtel would be planning when the service has to be done, so that the lesser impact get get impacted for the user, right? And since I'm in India, as you could see that the maintenance activity and the disruption would happen from 1 a.m. to 3 a.m., right? Obviously, I'm not going to work on the time, right? So I'm not, nothing critical also would be happening, right? So Airtel is able to pre-plan, and business also doesn't get affected, right? As you could see that maximum utility. Since I'm using the maximum resources of Airtel, I do pay more to Airtel, right? So Airtel is getting the benefit of maximum utility. And if when you see this, the next message, it is telling that due to a technical issue, you may experience a service interruption again. And it also says that the expected time to resume is 18th March 2022, right? So again, here you could see that based on the historical data, maybe on this particular day, there might be a huge consumption of Airtel broadband, right? Maybe due to some reasons, some campaigns or some normal reasons, there might be heavy usage, and due to the heavy usage, some towers are about to get killed, right? And that about to get failure, right, is being predicted by the machine learning algorithms, and it has been intimated to Airtel, and Airtel immediately takes a step to resolve that problem. And of course, this is a long-term benefit, because they would have set up this environment far before to detect the failures ahead, right? And that is helping them to resolve their downtime, right? And of course, not just a prediction kind of thing. The monitoring is also an aspect of IoT analytics. As you could see in this Power BI dashboard, this wind turbines data is constantly being pulled up by the system, and it is being visualized in the Power BI dashboard almost near real time, as you could see. And it is telling the total power generated is this much watts, and the current wind direction is west, wind speed is this, temperature is this, humidity is this. As you could see, the data comes from different sectors, right? Not just from the wind turbines. It is also showing the temperature data as well. And you could see the other end, the long-term setup. The machine learning algorithm predicts that the next maintenance would be around 22 days. So for the all the selected devices, right? If I'm selecting the particular wind farm and particular turbine, it will be, of course, saying that this particular wind farms, this particular turbine is going to incur the next maintenance maybe in next 2 days or in a couple of days, right? So this will be the dashboard that the end users will be. End users, I mean that the maintenance people will be using, and they'll see uh, from a remote place, and they'll see all the devices, all the things that happen in the devices completely in a digital manner. So how we could achieve this, right? Because the data is emitted by these devices, right? And we are able to see this data in a in such a beautiful dashboard, including map, line graphs, and card widgets, and this gauge widgets, and all those things. How this is getting happen? The very first step is we have to store the data, right? We have to store the data that emits from these devices into a database. I'm not going to talk about the what to say, the sensor or the pipeline and the MQTT framework and all those things, because you see in uh, more kind of tutorials about that as well. So let's consider that the data ingestion layer is working perfectly, and we are able to get all the data into the pipeline via the data ingestion layer, right? So the next part is storage layer. So when it comes to storage, each and every piece of data should have necessary details, not too much of details, right? Why I'm telling not too much of details is the data that is getting generated is like, so for subsequents will be getting data, right? Even though it is simple rows and columns that is being stored into a database, it would be trillions of rows of data when it's getting stored, right? So we cannot have as many columns as we wish. We should be very sure about choosing the tag set and field set while we are storing a specific information. Of course, in a realistic scenario, uh, we might have some changes on this tag set and field set to add more tags or to reduce the tags. That is fine. The ETL portion would take care to do the necessary cleanups. But we also need to consider that ETL should not go too much, right? It should be as smoother as possible. That whatever we store, we should be able to analyze it, right? So what I'm coming to say is the context is important while we store the data and while we analyze the data, right? When it comes to context, the categories, how we store the data, or the columns, we can say something like that, right? It is going to be the measurement name, what is going to be measured, and the tag set. Tag set is nothing but it identifies the particular device, what it is going to be. As we could see that the product has an ID, and that ID has been present, and that battery type has has a name, and that name is present, right? And also make sure that you store the data such that you do not join with what to say in SQL, we call it as uh, fact table, yeah, right? So for example, if in your analytics side, if you need the product name, then directly go ahead and have the product name itself, right? Don't mention it as ID 1 2 3 or something. If it is not identifiable, then directly have the name itself, right? Because if it is a kind of RDBMS, relational database management system, you can have this denormalization, right? Having all the IDs in the value table and having the facts in a fact table. Just join product ID with the product ID of product table, then fetch the product name. The joining is the thing that would be needed in case if you need the name of the product. But in time series, it's always uh, advisable to have one single table or maximum another table, right? To have all the information and to analyze on top of it. So it's up to the business decision. So basically, tax it helps to identify the type of product or the device itself, and the field set is nothing but whatever the measures which we are trying to capture on per that particular device, right? Here we could see that the voltage and the current and temperature and all those these three information, right? So maybe this data would be based on the electrical circuit board or kind of thing. If it is a wind turbine, obviously it is going to be the wind speed, the power generator, and the motion detection and all those things. If it is an oil gas, then obviously it is going to be again the temperature, because the oil tubes, right? It will get dived into the rigs, which might be hundreds or 200s or kilometers of depth, and it will get so heated so soon, right? So constantly the temperature, the humidity, and all those things will be captured in case of that example. So basically, field set is nothing but the parameters which you think the data has to be captured, which you might analyze or which you might monitor, right? This is the field set, and obviously timestamp in which particular point of time it has happened. And I think you could see that it is something as a random set of numbers, right? Because in time series, always the time will be stored as Unix timestamp, right? You can even check in internet that what is Unix timestamp. Because the reason why it has been stored like this is, it is the standard timestamp pattern which can be recognized by any tools, any analytics tool or any data tool, and which can be converted into any format. For example, I can convert this into an Indian IST format or PST format, whichever that makes sense, right? So that's why the timestamp will be stored in such a kind of format, Unix timestamp. So we just saw that tagging and ingesting data on all those things. Mostly the data that gets stored from IoT is going to be the sensor data, right? That's why I just show you an example of sensor data. However, I'll also tell what a time series data is and why IoT and time series data glues so together, right? So as the name says, time series, right? Just consider that the time flows something like this from left to right. And in this time span, some data gets captured in a regular interval, like as you see here. And there might be some data which might be captured in a non-regular interval also, right? As you could see. 1 second, 1 second, 1 second, 1 second. And this might get stored in 1 second. And after 10 minutes, this data might be stored. And after 5 minutes, this data might be stored. Like that it goes on. So as you could see in these examples, these are all very common examples which we see. The temperature, right? Obviously, it's an having it would be having a linear interval, right? The gaps would be linear, 5 minutes once or 1 hour once, because it makes sense. And whenever we go for the test like ECG or something, we could see the heart. They'll record the heartbeats into such a kind of graph, and they'll attach the report to us, right? And in even in your machine, Windows Explorer or the Task Manager, you could see that the CPU utilization, the CPU power, the CPU temperature, all of these would be captured, and we could see live live in our machines as well, right? So as you could see, all these are time series data, and of course these two examples. This data is nothing but the stock price data, which always constantly changes when the stock market is running, right? So ups and downs, and the value gets ups and downs all the time. And of course, developers would saw this such kind of log data, right? From the network perspective, the data would be present in both these formats, both in the visual format and also in the log format, right? In the log format, each and everything that happens within that software, within that application or within the device would be stored as as a textual data. As you could see, the timestamp is June 24th, so and so time, and what is its severity, and what is the event name, and what has happened actually. So this log data gets captured as a textual format based on the usage of the app. And later on, if something is needed, people would come back and see this log data to analyze something they would need. So we have these varieties of time series data, and there are mostly two types. As I told earlier, the metrics kind of data would be having irregular intervals, right? One second, 1 second, 1 second, 1 second kind of thing. Whereas the events kind of data would be having irregular intervals. In our previous example, the cluster monitoring and the health monitoring. This cluster monitoring, health monitoring, and even temperature monitoring, all these are metrics kind of based, because they capturing it in regular intervals only makes sense, right? Whereas if you could see this stock price and the logs data, only where something gets happened, the price actually gets changed, right? Similarly, only when something gets operated or the device is used, only then the data, the log gets generated, right? So these two examples are maybe we can consider as events, irregular data, right? Um, and of course, as I told earlier, before the analytics portion, there will always be three things. One is the ingestion, which actually lies as a middleware between the device and the software layer to capture the data. And next, there will be a pipeline to send the data captured to the database, and those data will be stored in this. And of course, when it comes to industrial IoT, it's going to be the mostly it's going to be the sensor data. And if it is sensor data, most optimal data pattern or the data nature of data would be the time series data, right? Because there is three characteristic a time series data has, right? One is immutable. What is meant by immutable, right? Let me tell you with a very simple example. Yeah, I hope you all saw the movie X-Men, right? The Hollywood movie X-Men. There, what do they call those people? The people with powers, right? They are called as mutants, right? The basic word, the mutants, means change, right? So they'll be able to change or change the behavior or change based on their actions. They'll be able to generate powers. But as humans, we are not. We are immutants, right? We don't have that special power like mutants have. The mutants will be having special abilities. They can enable and disable. They can change based on the times, right? So let's come back from the Hollywood example. What is meant by immutable? What is meant by immutable in terms of time series data? There is a device that emits a data that tells about that particular device's temperature or that the rotation per minute kind of information, right? And it sends to the database. The time passes, right? So that's all. That is not changeable at all, right? If you change yesterday, this particular device has rotated from 3 to 30, then there is no meaning of capturing the data itself, right? So the time series data itself will not allow to change the data, right? Maybe even this for this also I can say some examples. The phone call records, right? The whatever the phones using our mobile, whomever we call, all those the numbers, the time, the duration, from where we call, how long we call, all those information gets stored into the network provider's database, right? And whenever the police or some people would ask, they have the rights to see all those data, right? What in case that particular database is mutable, right? Then there is no meaning or there to have the changed data in that case, right? So that is another example of immutable database. Similarly, the time series data also should be in an immutable fashion, should be stored in an immutable fashion. That is one thing. And the next thing is always there should be the timestamp, right? The timestamp is very must for a time series data or an IoT data, right? If not, there is no meaning at all. And okay, I'll come back. Because as you could see in all these graphs, the time lays as the x-axis, right? Here the time, the 12 a.m. to a.m. is lies as the main axis, and of course here also, and even these graphs, everything, right? So the timestamp is very important when it comes to time series data, when it comes to IoT data as well. And apart from the time series, there can be one or more measures. There should be one or more measures like this temperature or humidity, this heartbeat data, the CPU utilization, the shared data, and all those things. And apart from that, there can be some dimensions as well. What I mean by dimensions is this particular information, the product ID or the battery type kind of information. Only then we'll be able to identify which particular ID that is. Okay, I'll come back to the slide. Fine. So when it comes to IoT analytics, it will be mostly from the second step, right? You would have saw this diagram in most of the tutorials. And when it comes to IoT, mostly the what happened kind of things won't be present, right? It will be like when something goes wrong or when something need to be done or some decision need to be took, they'll come into the IoT data and they'll do analysis that why it has happened, what is the time period it has happened, what are the devices that has affected, what are the parameters, other parameters that are there, all those things. And of course, the predictive and prescriptive analytics as well. And this is one simple example where you could see the data that gets captured from the IoT devices is being ingested into the IoT Edge runtime. And this IoT Edge runtime will be having the machine learning algorithm. It's the present within that IoT Edge itself, which will take decision based on the new data, and it will emit the decision accordingly, right? We allow the device itself to take decision. That's what this IoT Edge is major thing. And of course, this IoT Edge will pass on the data to IoT Hub, and then after some layers of travel, the data gets stored into the actual database. It could be the SQL database or even a time series database as well, as I told. And of course, the analysis phase begins in case the data can be monitored lively from the Power BI kind of dashboard, which I have showed the turbine mill dashboard. And in some cases, the machine learning happens to train the existing model based on the new data, right? And the machine learning models can be replaced based on time basis, maybe monthly ones or 15 days ones or yearly ones based on the business use case. And the latest model would be emitting the decisions based on the new data accordingly. And of course, now let us come to the implementation part. How the data management can be leveraged, right? One is we have open source tools like Apache HBase, Apache OpenTSDB, and there are many other tools. Influx Data, there. It is also an open source. So, and Cassandra, all these are open source, which you can use to store the data. So using using those things, as you could see that per second, right? For 1 second, around 10,500 requests has been handled by this particular node itself, right? And you could see that the number of records that has been written is around 4,088,094 rows have been recorded, right? Sorry, 4,08,894 records has been written, right? So as this, the time series database which we are choosing, right, for the IoT analytics, it should be write heavy database, right? Both the writes also might happen and read also might happen. That is what this Apache HBase is specialized for. When it comes to Hadoop, it is so efficient to handle immense read, but it can handle only one write at a time. That is the limitation of Hadoop. That's why Apache HBase was invented based on the BigQuery white paper released by Google. And this HBase will be capable of doing immense write and immense read, both at the same time, right? Write is, of course, understandable. The IoT sensors would produce more data, and those more data in a very short span of time, it has to be stored into the database. Why read? Why there is heavy read, right? Whenever there is a use case, right? Why such thing happen? and what would happen. And for those kind of diagnostic and predictive analytics, the data analyst or the data scientist would pull data from a longer period of time. And of course, longer period means longer, more rows of data, right? So the more rows of data has to be fetched, and that too in an aggregated manner, like average of this time duration, average of temperature, average of value, whatever it may be. The aggregation also should happen, and more data also has to be fetched. Likewise, this HBase and OpenTSDB is capable to handle that situation. This one you can install, of course, in an on-premise also, and you can install, leverage this service in cloud also. But if you want, if your space or business criteria is totally secure and not leveraged to include any cloud kind of thing, of course, the HBase and OpenTSDB acts as a very good architecture combo to store and read and write immense data, right? And of course, as you could see, this particular write and read is being done with this normal infrastructure. It is having 8 GB of RAM and 500 GB of hard disk, and just the normal 512 MB of JVM allocated to that machine, right? It is just a normal Windows Server machine. It is not a very super power computer which is costing so much. So it is a normal specification mission that is able to handle this particular role. And this is a very short intro of how this architecture is working. There would be a client computer where it will be the monitoring actually happens, and via this OpenTSDB node, the data ingestion initiates, and via this pipeline, the data gets stored from via OpenTSDB into HBase cluster, right? That's what you are seeing here. The three nodes of this.
Dinesh, just a quick alert.
Yeah.
You probably want to wrap up when you're ready.
Okay. I think I might need 3 more minutes. That's it.
Okay. Go ahead.
Yeah, sure. So this is in terms of on-premise sector. And when it comes to cloud, right, far more leverage can be done. And that's what I'm going to show you with the help of Azure Timeseries Insights service that is present in Microsoft Azure. So, and of course, this is the white paper which I just popped you up to do that HBase plus OpenTSDB infrastructure. You can refer it if you want. And let me show you the other thing, complete cloud, right? This particular portion, I'm not going to take much time. How the data ingestion happen, how the data is captured, and all those things. Just imagine that the data gets stored into Azure Timeseries Insights servers directly from the IoT devices and all the services that lies behind, as I mentioned earlier in the previous architecture screenshot, right? So once the data comes into Timeseries Insights, let us see from that particular pattern. As you could see, the hierarchy tab, right? We could easily see that these are the instances. Mostly we can take that this is one particular device, right? And what is the beauty of this is you can totally design this hierarchy model, how you want to design the instance, how you want to design the hierarchy, how you want to design the type. It's totally in your power. And for this demo, it's going to be the one device is going to be one instance. And when it comes to hierarchy, we'll be able to easily see that the plant and then unit and then system and the name, right? Like this, I have designed the hierarchy structure. And when it comes to types, we will be able to group the devices in different types of sector: turbine sector, weather sensor, safety sensor, gearbox sensor, position sensor, and all those things. So now this is a kind of data model space. And now let us come to the analytics space. As you could see, in a very simple user interface, I am simply able to select the hierarchy and I'm able to see all the plans that are present over here. So within this plan, I'm able to see that the devices are grouped into the respective hierarchies. Now let me quickly select which one I want to analyze. And now I will go back and select some other thing. From this workstation, let me select the parameter gearbox oil, the state of gearbox oil, and the state of gearbox temperature. So as you could see, once I selected, I'm able to see the selected parameters. It's been displayed over here. And for the demo purpose, let me clean it up, the old ones. So as you could see, I'm able to see the two parameters and what is the data difference over the time. And I have the time filter, right? Where I am able to see, choose the number of days and the hours for which I am going to analyze. And once I see something and there is some spike over here, I can simply select on that, go to the marker and simply select on that marker, and I can define that marker and mark maybe another engineer that, hey, Arun, can you check this anomaly? Right? So the not just analysis, the collaboration also happens all within the platform itself, right? So, and you could easily understand that what is the now which lane it has been showing. So the first lane and the last lane, and this is another lane as well. So let me add another parameter, the active warnings state parameter, and again it would be having a different layer of warning, right? The red, green, and all those things, as you could see here. And even though it is an anomaly data, there is no red warning is there. I'm able to see clearly that nothing has gone wrong much, but it is good to see for a later point of time. And of course, I'll be able to zoom in the data as much I want, and I'll be able to see the lanes in a lane pattern or in a shared pattern or in a overlapped pattern also based on my view. And I can even change the type of chart which has been displayed. Maybe if there are more than one metrics, I can change it to the scatter plot, or if it is decent to go with the line chart itself, means I can stay with the line chart itself. So let me come back to the slide again. And as you could see here, there will be always an argument, especially in industry point of term, because there will be a lot of firewall between the things, right? To allow the data to get passed on. So just think on these four factors. When it is going to be cloud, you can be conservative on investment. You need not invest in whole infra, one. Next, you can scale either over storage or the compute part. The storage can be same, and for the to handle more number of requests alone, you can scale that the device. And next, you can simply drive into the use case when you go for the cloud infra. And next, you can always be on top of the security pattern. You don't need to worry because the Azure cloud or the AWS cloud would take care of the security. And these are some resources where I have pulled all this information. And of course, thank you.